Okay, so we are going to look at our first example here. Find the absolute maximum and minimum values of f of x, which equals 2x cubed plus 15 halves x squared minus 9x on the interval from -4 to 2. Okay, so those are our x values for the endpoints of the interval. And we want to find the absolute maximum and minimum values of the function. So values of f of x, those are going to be like y values. And we're going to follow our little series of steps from right above here. And we actually just noted up on these what's an x value versus what's a y value. In our first step, we're going to find the critical points of our function that are inside the interval. And those critical points are going to be, they're going to come out as x values. So we'll find the critical points, those are the x's, and then we'll use those x's to find the value of the function f. So that'd be a y value at each critical point and at our endpoints. And then we can compare our y values because the biggest y value will be our absolute max. The smallest y value is our absolute min on the interval. So yeah, that's the layout. So step one, we want to find critical points for this thing. Okay, step one, critical points or critical numbers. Okay, critical numbers. And remember those critical points, critical numbers all rely on the derivative. Okay, it's either where the derivative equals 0 or where the derivative is undefined. So let's take the derivative of our function here, f prime of x. And no need to do anything fancy with this. We can just use power rule. So that would give us 6x squared. And then plus 15x minus 9. And that would be our derivative. And we want to take this and see where this equals 0 and where it's undefined. Okay. So that would be the things to look for our critical points. Now, the second one of those, where is f prime of c undefined? For this particular function, that would be nowhere, because this is a nice polynomial quadratic type of function there. There aren't any points where this function is going to be undefined. So that doesn't happen anywhere. So we can kind of rule that option out for right now. We can really just focus on where the derivative is going to equal 0. Okay, so make it equal 0. All right, 6x squared plus 15x minus 9 equals 0. And we can totally do some factoring here. We can factor out a 3 for starters. Okay, take a 3 out of everything. And then this quadratic can also be factored. And it looked like a few of us could use a little brushing up on our factoring. So you might want to review that if things like this give you some trouble, especially these quadratics where there's a number other than 1 as the first coefficient. You might want to review a few of those if you're a little hesitant about factoring things like this. So this is going to factor into 2x minus 1 and x plus 3 there. Okay, if you FOIL it back out, yeah, that does work out, so cool. So now we have our formula, our function factored. equals 0, that's good, because now we can take each factor and set it equal to 0. And so we'll come out with x equals 1/2 and x equals -3. Okay, and so those are our critical points. Okay, critical points right there and right, whoops, right there. And you could call those like c equals 1/2 and c equals -3. That's fine too, since I know that's how we did it in the definition here. But you can also leave them as x. That's all right with me. We're just finding the constant value for c there. So there we go. Okay, so there are our critical points. And I'm going to give myself a little bit more space here so that we can find some y values to go with these x values. Okay. Oops. Missed a little bit of that, but critical points. There we go. So there's our first step. Find the critical points. Now we need to find the value of our function at each critical point and at our two endpoints. So step 2, values of the original function, f of x. So a common mistake on this type of problem is actually plugging the values back into the derivative, because it's kind of what people have used more recently in the problem. And that doesn't work out because remember, we're looking for the highest and lowest values on the graph of the function in this interval. So yeah, we don't want to use the derivative for that. We want to get the y values of the original thing. So we will find f of our critical points, f of 1/2, f of -3, and then we also need our endpoints, which are -4 and +2. Okay. And for these, especially with like f of 1/2 here, plugging that into the function can be done by hand, but you could also use your calculator on this. Yeah, because doing like 1/2 cubed is not that bad, 1/8. But when you do that, you'd get, I did it out by hand earlier. It was -2 3/8. But you could do it on the calculator and get -2.375, and that would be all right. That suffices. We're just looking for a y value there. All right. Then f of -3, same type of thing there. You plug it back into the original function. And with the whole numbers, it turns out a little nicer to calculate. And this one turns out to be, oh, not quite so nice, 40.5, 40 and 1/2. Probably the awkward bit comes from the multiplying by 15 halves there. Then you plug in -4, same idea. For that, you would get 28. If you plug in 2, turns out you also get 28. Okay. So I guess I could clarify that we plugged in -4 for that, just so those 28s don't look totally random, because they're not. It's just from plugging into the function. And the fact that both endpoints here gave us the same y value, that's just a coincidence for this particular function and this particular interval. That's not something that's always going to happen. Okay, So f of -4 and f of 2 both turned out to be 28. So that's step 2. We've got some y values here. Step 3, our last step, is to look at those y values and pick out the largest and smallest ones. So the largest would be your absolute maximum for the interval. The smallest would be your absolute minimum for the interval. So we can see pretty clearly here now that we've got the y values all laid out for us. The largest y value is that 40.5, f of -3 there. And then the smallest is this negative value, -2.375. So that's going to be our minimum. And so to finish off the problem, which I kind of ran out of room here, let me move some things around so that we can get our sweet conclusion on this for the absolute max and min. All right. So we would conclude for our answer here that the absolute maximum value is f of -3, oops, -3 there, which equals 40.5. And the absolute minimum value is f of 1/2, which was -2.375. Okay, and so that would be our solution for this. Okay, so one note here before I end the recording. When you are entering your answers, you might want to be careful as to how you do it. In MyMathLab, check if they want you to type in like f of -3, or if they just want you to type in 40.5, or if they want it as a fraction. Same thing with your absolute minimum. Do they want f of 1/2? Do they want you to round to a certain number of decimal places? Watch out for that. If this is an exam situation, let's see. For those, I would be fine with, you know, whatever number of decimal places on that second value. You could keep as is, or if I wanted specific decimal places, I would tell you. But I usually like to write both forms for my answers. So like on a test situation, you probably should write that full like f of 1/2 equals -2.375. That way I know that you found the right x value and that you found the right y value. I mean, of course, I will also be looking through your work with the critical points and stuff, but for that final answer, this is generally how I would write them. So if you want to adopt that as well, I think it would probably be kind of a good move to make sure that you're safe with your answer formatting. Okay, so there's our absolute maximum and minimum values for this.